Hi guys, welcome to the sixth video of module 9. And here comes my favorite part about the convolution layer, that is output shapes of CONv2d layer. The first thing is I'll be telling you what is the formula that you can use in order to get this kind of output shape, that is about the width and the height of the image. And then what about the number of channels? Well, there is a direct relationship of these filters with the channels, as you know. So I'll also be talking about that and tell you about how to get an complete output shape of the CONv2d layer. So let's get started. Now let's talk about how we can get the output shape by implementing the convolution operation in between the input image and the filters. And we also call this output as the feature map. So what are the dimensions of this feature map? How can we calculate this? So over here, we first need to understand that how does this convolution operation works if I am having more than one channel in a filter and if I am having more than one channel in an input image. So let's first of all focus on this input image. Clearly we can see that we are having 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. So it's a 5 cross 5 input image on top of which we are having one padding layer. So together it's going to become 7 cross 7. But along with that, I am having another 7 cross 7 and another 7 cross 7 over here. So there are 3 different channels in this input image. Now because there are 3 different channels in an input image, the filter that I'll be requiring over here will also be of 3 channel. Now what is the reason that the filter will also have the 3 channel? It is because each and every channel of the filter will be convolved with its respective channels in the input image. That means the first channel filter will be convolved with the first channel in the input image. The second channel from the filter will be convolved only with the second channel in your input image. And similarly, the third channel of your filter will be convolved only with the third channel of the input image. So let's say in your input image you had 8 different depths, or let's say 8 different channels. Your filter that you will have that's going to be convolved with this image must have 8 channels as well. Only then this kind of multiplications are going to happen in a proper way. So currently, because we are having 3 different channels in the input image, this one filter is consisting of 3 channels as well. But over here, I am also having another filter. Again, because I'm trying to convolve this filter with this input image, even over here, I am having 3 different channels. Now you might have this question that why do we have 2 filters over here? Well, to answer that question, we can have as many filters over here. Let's say if I want to have 8 different patterns that I want to decode, I'll be having 8 different filters for that. Initially, I don't know how the filters are going to look like. But I can have 8 random filters that's going to be learned in the back propagation and get towards its optimal value. So over here, let's see if I want to decode 2 different type of patterns, I'll be requiring 2 different filters initially with random weights, right? So one filter is going to give you one output, another filter is going to give you another output. And therefore, the number of channels are really going to play a crucial role. If there are 3 channels in the input image, each and every filter will also have 3 channels. Only then the matrix multiplication is going to happen in a proper way. And then you get this kind of outputs. The first filter will give you the first output. The second filter will give you second output. Like this, if you're having 8 different filters, you will have 8 different outputs over here. So if I talk about the final dimension in the output shape, that is the number of channels in the output, it is always going to be equal to the number of channels. So as I just explained, if I was having 5 different filters, the number of channels in the output will be 5. Each output is the output of the respective filter. In this case, this filter, if I convolve with this image, this is the output. If I convolve this filter with this input image, this is the output. So I hope you are able to understand that how we are able to get the final dimension of the output shape. Now if I talk about how do you get the width and the height of the output, you can simply go ahead and straightforward use this formula. I'll just tell you what is the meaning of I, F, P and S. Just plug in the numbers over here. You will be getting 3 and 3. You can once implement this for the height part, where if you are going to consider the height of the input image, you also consider the height of the filter. If you are talking about the width of the input image, you also consider the width of the filter. So if you're talking about height, you will be getting the height of the output. If you're talking about the width, you will be getting the width of the output. In this case, because both of them are square, the output will also be a square image. So over here, I represents the input shape. So let's say we are having 5. It's not 7, okay? 7, it's after adding the padding. And that is going to be taken care over here because of the 2 into P. So initially, if I talk about I is the actual size of the input image. So in this case, it's 5. So if I just write this kind of information, I is equal to 5. And then what is the F? F is the size of the filter. We don't care about the how many channels are there. We just care about the dimensions of that. That what is the height, what is the width. Right now, because both are same, I'll just use it for one time. That is going to be 3 in this case, right? 3 cross 3, so 3. Then there is one padding layer on top of the input image, and therefore plus 2 times 1. 1 because one padding layer is there. Now if you do this 5 plus 2, that's how it becomes 7. But we are not giving this I plus 2P together, we are giving it separately. So always keep in mind that I is the actual shape of the input image. And then you give the extra padding layer like this. Once this is done, you will divide this value with the strides. And if you can notice what is the value of stride, it is starting from, let's say, this particular thing. And the next time it's going to shift, it's going to start from this column. So it's going to have a 2 shift. And therefore the stride value is going to be 2. Now do this fraction. Whatever is the output of this fraction, just add 1 on top of that. And that will be your output dimension. Let's say for a height or even for a width, the formula is just the same. And because the input height and the width and the filters are same over here, the output shape, as I mentioned, will also be a square shape. So we just need to implement it once. So what is 5 minus 3? 5 minus 3 is 2. 2 plus 2 is 4. 4 divided by 2 is 2. So this whole fraction output is going to be 2. Add plus 1 to that, output is 3. So that's how we are going to get 3 and 3 over here. Okay? And 2 you already know why the 2 is there. So that's exactly how you calculate the output shape after the convolution operation has been implemented between the filters and the input image. So yeah, I hope you were able to understand this one of the most interesting part over here. That is how to get the output shape from the convolution operation between an input image and the filters that you are having in the picture. Now in the next video, I'll be talking about how you can calculate the total number of trainable parameters in this convolution layer.